Okay, so today we are going to cover section 6 of chapter 5. Now, notice in the description, it says that we're also going to cover an indirect proof. However, because the normal proofs that we've been doing, the 2-column, have been challenging enough, we are not going to be testing you on indirect proof, and you will not have any homework questions on indirect proof. Now, what an indirect proof is, by definition, what you're going to do is you're going to start by making a temporary assumption that the desired conclusion is false. Then you're going to try to show that that assumption is going to lead to something that's logically impossible, and then from there you'd have to try to prove it by contradiction. So you sort of have to think backwards when you do an indirect proof. So we will not be doing them in this course. You will not be responsible for indirect proof. So today, the only thing I'm going to talk about, again, are more inequalities. But this time it'll be in 2 triangles. And the first one that we're going to see is the triangle, the Hinge Theorem. This actually has a name. So if you were to use this in a proof, you could just put Hinge Theorem. And I'm going to demonstrate what the Hinge Theorem looks like. And I'm going to use my scissors and use the point where they meet as my hinge. Now, you could also think of this as a door, the hinge on a door. But what this theorem states is that if 2 sides of one triangle are congruent to 2 sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. I'm going to show you what I mean by this with my scissors momentarily. Okay, so what's going to be important here for the Hinge Theorem is that you have 2 pairs of sides that have congruency marks. So notice right here on this side is congruent to this one, and this one is congruent to this one. Now, this little red shading area and the blue doesn't indicate that these angles are congruent. They're telling us here that A is bigger than D. Now, if it helps you to put in a number, just so you can compare, we could say that angle A is 50 and angle D is 40, and that would give us something that we could compare. So I could put 50 here, 40 here, and we saw yesterday that the longer side is always opposite the bigger angle. So notice here, instead of being within the same triangle, now we're comparing 2 triangles. So we can see that the 50 is the bigger angle. So this tells me that BC is going to be bigger than EF. So that's what they wrote here. So, okay, now the converse of the Hinge Theorem, this time they're going to give us information about the sides, so then we can figure out which angle is bigger. So again, here, the red side is larger than the blue side, so that tells me that the red angle is bigger. So again, it's saying if 2 sides of one triangle are congruent to 2 sides of another triangle, and the third side of the first triangle is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So again, they still need to have congruent sides in order to use these theorems. But again, the bigger side is opposite the bigger angle. Let's apply it. Okay, so the next one, we're going to take this Hinge Theorem. So we're going to be using the Hinge Theorem to solve this one. So again, it's telling me that D is the midpoint. So this tells me that this piece is congruent to this. Now, the 2 triangles I'm referring to are this red one right here, and then the green one over here. Now, in order to use the Hinge Theorem, we need to find 2 sides that are congruent. Well, I've got the one from the midpoint, and then I have the other side from the reflexive side. So now I'm going to look to see, and they're also telling me that the measure of angle 1 is smaller than the measure of angle 2. So again, if it helps you to give them numbers, again, I could do the same 2 numbers. Like I could say, it looks like it's greater. So let's say this one is, angle 2 is 110, and let's say this one's 80. Just give them numbers that satisfy the inequality. So this could be 80, and this one could be 110. So now that I have angle measures in here, which side's going to be bigger, AB or BC? Okay, so then I can say that AB is greater than BC. This is what it's asking me, what can you deduce? Or what can you determine from the picture using the Hinge theorem? So as soon as you see that the angle 2 is the bigger angle, then you know the side across from it is going to be the longer side. All right, so here they want us to fill in one of these symbols in here, comparing the two angles. Now, let's go ahead and let me outline the two triangles we're referring to. So that's that one. And here's the other one. Now, remember, in order to use, now we're using the converse this time, we need to find congruent sides. So we have the reflexive, and then I can see that this side, even though it's not drawn to scale, is congruent to this one. So now to figure out which angle is bigger, the one's going to look across. He sees the 4. And then the 2 looks across. He sees the 3. Which side is bigger, 3 or 4? The 4. So that tells me angle 1 is the bigger angle. So for this one, we just use the converse of the Hinge theorem, because they gave us information about the sides. All right, we need to find the range of values that K can take on. Now, which angle is going to be bigger? Is it going to be this one, or is it going to be this one? And how do I know? Is it red or blue? Okay, it's going to be the blue because it's across from the 19. So my inequality that I'm going to solve is, I know that the red one, the 5K minus 12, has to be less than 38. So I know that that angle can't be more than 38 degrees because it's the smaller angle. Everybody with me on that? All right, so now I'm going to go ahead and solve this. And K is less than 50. Divide by 5. So K has to be less than 10. Now, that's as big as it could get, but I also have to figure out how small it can get. So you know that it can't be 0 degrees. So what I'm going to do is make 5K minus 12, and it's got to be greater than 0 degrees. It could be a 1 degree angle as long as it's less than 38. And now I'll solve this one. 5K greater than 12. Divide by 5. And K has to be greater than 12/5, but less than 10. So if you want to write it compoundly, you can. You could do 12 over 5, then put the K, and then the 10. So it's got to be, K has to be a number that's in between 12 over 5, which is like 2 2/5, but less than 10. So you can do it like this. So in between these, it's got to satisfy both. Yes? Because we know that this angle here can be 1 degree, it could be 2 degrees. It's got to be a number that's greater than, you don't have to do that, you can delete them, yeah. All right, everybody good? All right, so that is it. You do have homework for this lesson. It is due tomorrow.